All right, so hopefully back again. Took me maybe a minute or two to upload that last one and get the stream going again. Take a moment to make sure the audio is working. The video is coming through. Hello, hello. Audio is working. The video is coming through. Hello, hello. Audio is working. The video is coming through. Hello, hello. Okay, we'll pause that. Pop out the chat. Chat is here. Right, so we'll keep going. Yeah, I think we're good to go. So next question is subarray sum is divisible by k. I already pulled it up. Given an integer array nums and an integer k, return the number of non-empty subarrays that have a sum that's divisible by k. A subarray is a contiguous part of an array. Okay. Non-empty subarrays that have a sum divisible by k. Okay, interesting. Not so obvious how to do this. There's a quadratic number of so I don't know the answer to this immediately. I don't think it's too hard to figure out, but I don't know the answer. So the number of subarrays is quadratic. That's number one. Number two, so you won't be able to do this in quadratic time though because of the time bounds. So it's got to be faster than quadratic time, even though there's a quadratic number of subarrays. So the question is, can you count like more than one of these subarrays at one instance? I think you can use maybe you can use a sliding, a two-pointer solution, sliding window solution, possibly. So I don't know about that though, because you could. I was gonna say you could try to do something where you take all of these values modulo k, but I don't think that's really a good idea. I don't know if that really matters, quite frankly. Also, the negative numbers, if you take a negative number mod 5, don't think you get 0. Well, maybe you get 0, I don't know. Yeah, I don't know what negative numbers modulo would mod k actually is in C++. Not so sure. But anyway, actually, let me see, find out what's 5 mod 5. Or negative 5 mod 5. I've not needed to do this ever. I've never needed to take the modulo value of something that's negative. This is the first time. Output 0. I was like negative 6, negative 10. Yeah, okay. Cool. I think I understand. All right, it's fine. Anyway, so Okay, I think I know what to do. I'm wondering if I could use a frequency map of some kind. Also, what is the value for k? Okay, 10,000. Okay, maybe use a maybe use a frequency map. What I'm wondering is maybe I can move from left to right and count the frequency of take things modulo k and count the frequency of those values. It's a little more complicated if I don't know. Well, let's do a regular frequency map rather than I was gonna think about using an array as the frequency map, but I could just use a regular frequency map, a hash map as a frequency map. But anyway, so let's suppose that I have a frequency map of the values modulo k. Then, and actually, I can actually convert all of the I could actually convert all the values to positive values mod k. So actually that's fine. I could use an array for the frequency map. That's actually fine. But anyway, so let's say I have the frequency map. However I'd end up doing it. Frequency map from left to right, and everything is modulo k. The question is, when I'm looking at a certain number, how far to the left can I go to create a sum, right? That ultimately that sum gives me modulo k. Well, wondering if I want a frequency map of the prefix sum, something like that. Because it's not that I need to go. I need to add as I look to the left side. I have to add all the values in between, and so I really want the sum from the position that I'm at all the way to the left. I count the number of those sums that Yeah, it's not so obvious. Excuse me. Thinking here, thinking. I want to say it's something with a frequency map. I think that's the way to go. But it's not so obvious how to do it. Definitely I can translate everything into modulo k, the positive modulo k values. That's fine. Then the question becomes, what about what about gee, I don't know. As I move from left to right, okay, let's say I can get all the prefix sums. Let's start with that. That I can do that in linear time. And now I want to get all the sums that don't include the first value. Modify all of the prefix sums by that amount. Well, if I subtract, I guess I can get the frequency of the prefix sums, and then now I can subtract from left to right. I can get, if I subtract the first value and whatever I subtract that from, modulo k, right? So I guess whatever the value is, subtract and add, add k, mod k, that kind of thing. I get some number. So there's some value of k that I subtract this, some not value of k, but some, some equivalence class, right? How do I phrase it exactly? We'll call it alpha, some alpha that when I subtract this value from alpha, call it v, subtract v from alpha, it should be equal to 0. So alpha should therefore be equal to v. So I'm going to subtract, and this is a prefix sum again, modulo k. So when I subtract this prefix sum from alpha, it should be equal to that value, really. And again, this prefix is modulo k and all that. Positive modulo k. I think I would add all of those values to my sum in that frequency map. I think I do this in linear time in that way. Let me try that. It's a little bit complicated, but it goes something like the following. So we're going to have an integer array frequency size k. Then we're going to say just fill this initially with zeros. We're going to say transform nums with the following. X mod k plus k mod k. All right, something like this. Okay, now everything is positive. Now that I've got these things, I'm gonna do it on time, by the way. Okay, 12 minutes. I can build the frequency, building the prefix. So int prefix is 0. For int I is 0, or just const int x in nums, prefix plus equals x, frequency prefix mod equals k, frequency of prefix plus plus. Okay, now I think I do the same thing again. So I have a result, and this result will fit. If you square this, it'll fit. It's 9 times 10 to the 8th. That should fit in an integer, a 32-bit integer. Now we do almost the same thing again, calculating this prefix. But now we take this result and we add the frequency of that prefix. Because so I'm going to just add. That's confusing. Because when I set that back to 0, because I'm now going to remove also by the way, Start this off with the zeros. Yeah, the rest of this is going to be removing the first element, or one element at a time. That section of those section of elements, which it's going to be removing that, which means that the prefix sum, when it's equal to that value, removing that puts you at 0, which is divisible by k. You put mod k, 0 mod k, something like this. This gives me close to what I'm after. Totally didn't think I would need to do that. I forgot that k needs to be captured. Oh, it's got to be written to. So I really don't like these pictures on. I don't like these pictures that are first, last, first. Yeah, okay. Really don't like these pictures that are just default on the Brave browser when they get when I have a new tab. Yeah, something like this. 19 expected 7. No. Output is 1. What do you mean output is 1? What? How'd you get 1? In this case, how'd you get 1? I did something wrong here. Zero, 1. So, okay, somehow x is in get 5, mod 9 is 5, plus 9, mod 9 is 5. This should just be 5. And then this should be, what is going on? What is happening? One, 2, 3, 4, 5, 6. Oh. Oh. Okay. I get it. Okay, that's my mistake. I didn't really think about that. Okay. I brain was just not working for a second there. Yeah. Oh my goodness. Just didn't think that through at all. Oh man, that's bad. Yeah. Okay. I didn't really think about how this is calculated. What about this one? I got 1 frequency 10104 and results 18. So 5, we should get 400. This should be like 3, 2, and 1. And so the frequency for this sum is going to be, so we get 4 once, we get 4 twice, we get 4 3 times. Then we get 3 once, 0, 1, 2, 3, 4. 0, 1, 2, 3. We get, should be 3 once here. Oh no, 4 minus 2. That's 2. Yeah, 0, 1, 2. Then 2 minus 3 is -1, which is 4 again. So we get 1, 2, 3, 4 times we get 4. And then one more time we get 0. 0, 1, 2, 3, 4. And the suggestion is, oh, I see. One more detail. I think that happens too. Yeah. Which actually, in that case, I had it right the first time. Maybe I had it right the first time. Oh boy. Maybe. There we go. Okay. That's a little confusing. Whoops. I think I had the right idea. I think so. I just did not implement this correctly. Pretty good idea. Pretty solid. Let me get some more test cases going here. Just have some random things in here. Let's do 1, 100, 20. What are all the possibilities? K could be 2. K has to be at least 2. Okay, let's try these things. What am I doing here? Okay, maybe I could do something like this. 1, 2, 3, 4, 5. Let's do like 6. Let's do 5, 4, 3, 2, 1. Let's do like 3, and then come back and test one more, try to do one more unusual test case type of a thing. Nums could be a size 1, K is 2. So let's try that. 1 and K is 2. See how that goes. All right, I'm going to go for it. Could be wrong, but hopefully I got it. Hey, you got there. Sweet. That was a clever idea. Pretty relatively fast, not too crazy. All right, I'll submit this like 5 times, do the same deal. Submit 5 times, and then stop streaming, and then restart the stream up. I have to do like a little bit of adjusting. I have to do upload a thumbnail, and then 1, 2, 3, 4, 5. Yeah, I have to submit, stop streaming, and then upload a thumbnail. This is maybe not as fast as it could be. I might not actually need to transform the elements directly here. Like I might be able to do this same thing here, but well, yeah, I think this may be unnecessary. Naturally is what I'm getting at here. Maybe I can do mod equals the prefix, like prefix equals prefix mod. Yeah, whatever. I'm not gonna do all that. That's fine. Just do it once. Never mind. It's fine. 1, 2, 3, 4. There's probably a faster way to do this. This is technically linear time. 1, 2, 3, 4. We'll do one more. It could be, maybe it could be faster. I don't know. Maybe this could be faster. There's probably a way to do it faster, but this is pretty good. This is reasonable. There might be some finagling that one can do to make this even faster. Very good. So yeah, that's linear time though. Linear time, and maybe there's some optimization there that I might be missing. Just like avoiding some divisions and things. Okay. Let me stop there, and then I'll start another one. So yeah, thanks for watching. If you like the stream, don't forget to like the video and follow, subscribe.